Well, hi, and welcome to my shop, and thanks so much for coming and joining me here today. It's March 27th, almost the end of March, and oh my gosh, there's fresh snow on the ground. It's -7 outside. My cats are depressed. Oh my gosh. But, on the other hand, got this radio working yesterday, except for a pretty terrible whine that's in it. Whining sound, which I'm gotta guess has to do with the power supply filter. Power supplies in this part of the radio here. So that's what I'm going to focus on today and hopefully resolve. It shouldn't be too tough. The challenging part about it is that someone has already altered the circuitry in the power supply area, and I don't think they've done anything unusual, so it shouldn't be too much of a problem to sort out and decide how to go about eliminating what I'm pretty sure is basically a power supply filter problem. Maybe a bad capacitor or lack of a capacitor or something of that sort. So we're going to take a look inside here and examine what they've done and look for the capacitors and all that kind of stuff, and then get busy getting rid of that terrible whine that comes out of that radio. Okay, well, I might take a sudden change of direction here. I just got off the phone with the owner. He's watched my first video here and chatted with me a little bit on the phone. Said he doesn't actually prefer this radio, the Wunderbar radio. He prefers the other one, which is a non-Wunderbar radio of the same sort. Basically, he said the problem with the other radio is a low output on the volume, and that this one, even when he acquired it from the person who did the work on it, he was told the Wunderbar didn't quite operate properly and some other stuff and that, and he likes to look at the other radio better than this one. So I think I'm going to solder back this connection, put the radio back together, bring the other radio out, we'll turn it on, fire it up, and see what we get out of it, and then we'll approach what is probably a low volume problem, and it could just simply be a weak tube, but nothing more than that. The other radio, though, has had no work done in it, so it's got the original capacitors. Not that there's many of them in here, so I may attend to that side of it too. Okay, so a chance to take a little break now, and we'll just switch radios at this point. Okay, this radio out. By the way, there was another interesting little thing I didn't realize about the Wunderbar radio, which I may as well show you before it goes away. That's just a little door. So a little fingernail grip here. Pop that door open, and that's how you adjust the presets, I believe, for these buttons. And then these buttons aren't mechanical. They're triggering the search function, I think, and it's searching to the next setting. So this button, oh, yeah, it doesn't really feel mechanical. You know, a lot of car radios, when you push these buttons, you can feel the mechanism being pushed around. You're the motor. But anyway, I just thought I'd show you that. I'm not so sure about exactly how it all works, but away it goes in favor of this radio here, which looks extremely similar, except no Wunderbar. And this is probably, feels like there's a finger grip there. You probably, I'm not going to try it. Somehow you have to be able to set these buttons to the channels you want to listen to, the stations you want to listen to. So in some radios, most of these, you pull it out and you shove it back in, and presto, it's done. So I'm going to get rid of this power supply. The power supplies are interchangeable. He's given me an important clue. He's told me that this is the other power supply now, and output, speaker output. He's told me that regardless of which power supply you put on this radio, the output from this radio remains low. So that's an important clue. That means it's not going to be the output tubes here. So now this radio has not been altered. It has the original, not an original, but it has a mechanical vibrator in it, and the rectifier tube here, which is an OZ4 rectifier tube. And he warned me about a pin problem with this tube. I have a couple more of those anyway, at least a couple more. Probably in working condition, so if we end up ruining this one, it's not the end of the world either. Okay, so I'm going to take a minute and wire this guy up, and then we're going to try him out and see what we get with this guy. Always a little mystery to figure out. So this radio has these two wires coming out the side and no plugs or jacks on it. These are the ones I used to supply the power. Right, the black one was the radio and the white one was going to be the light here. This radio is a little different. There are no wires sticking out, but what it does have is it has this jack, so you've got to assume that this is the power in for sure. One of these is going to be grounded to the chassis and the other one's going to be the power in. So I'm just going to get my not so trusty ohm meter, soon to be retired from service in my shop here, this guy, in favor of the new Allen meter that is on its way here. An Allen meter. So exciting. Okay. Which one goes to ground? Let's put this on the 200 scale here. 0 is 0 today. And we'll make a nice connection here. Is it this one? Wait a minute, how come you're still saying 0? 0, 0 all the time. This is why the Allen meter is needed. Sooner or later I'm going to be fooled by this one. Let's try that again. 0 is now 0.1 5. Let's turn this off. Let's try it again. Open. Open. Come on. Sure, I'm making a ground. Really? Neither one's going to show? That's not helping very much. On. Five. 1.9. Why wouldn't it be 0? He says, asking wistfully. Well, that's fairly strong evidence, but not complete evidence. I think I'm going to do a little examination in here, because I don't care to hook this up backwards, and we're going to have to get inside here anyway, because while it's here with me, I'm going to give it the capacitor treatment, and we got to get it the tubes for testing, because I'm going to guess the low output is due to a weak tube. Where'd that go? A screw that just disappeared into thin air there. How did that happen? And now it's reappeared. Too short in the front, too long in the back. Here we are. Yeah, look at this. Looks a lot different, doesn't it, inside? Looks very different inside. Pretty egregious looking capacitors here. Lots of dirt, of course, in an automobile situation. Okay. Power. I can't see it here. I gotta take the other part off. Let's pull this out here. Wire this up a little prematurely to the other unit. Two long screws. Whoops. Two short screws. Now I think I heard on the radio, I didn't want to hear this, but 10 to 15 centimeters of snow is coming. I can't believe it. I haven't told my cats about it yet. They'll blame me for it if I tell them about it, so I'm just going to let them find out. Oh. Not helping. Yikes. There we go. Information in it. GM Auto Radio Model 561. Made in Canada. Patented 1956 inclusive. And I think this is in a 1957 car. 12, it's probably BE6, AU6, V12 V6, 12 V6. Oh, yeah, and oh, this is 12 V6. Yeah, sure. Instead of a 6 V6, 12 V6. That's these two tubes here. They look high mileage when I look at them. BA6, BE6. Okay. Hopefully I don't have any trouble testing those tubes. Here we are. Where's the power coming in? Power's coming in here. And there's an odd component here. What is this bolted to the side of the radio? And there's two leads. So the two prongs must go to these two leads, and they go to two different switches on the back of the switch, switching both, which is why both read open circuit when the switch was off. I'm not quite sure what this is. Very odd looking thing. Some kind of capacitor of some sort, maybe a noise eliminating capacitor arrangement there. Let's take a look with a closer camera at it. Because, you know, in 1957, cars had a lot of ignition noise. This strange looking thing here. So here's the input terminals. One of them looks more protected than the other. This upper one looks more protected. This lower one doesn't look very protected. This is probably the ground, but why not get a 0 on it? Can we see what it's doing in here? It's way down below that, down under. I can't quite see it. Well, this should appear on the schematic for what it is. There's the two wires going over to the back of the switch. Well, I've got this camera going, so you know, any one of these tubes could be weak. Just trying to wake the tube up in the socket a little bit. I don't want to wiggle it too much. So I think an issue in these is the tube shaking right out of the socket because you're driving down gravel roads. back in the day. Here's some, yeah, that's a resistor with a coil wrapped around it. Yikes. Here's the mechanism, which I believe is working just fine in this radio. Let me push a button and we'll see something move. I have no reason to think it's not okay. Right, so the issue is which one is grounded. A little tricky to see here. And I don't have a schematic for this particular radio. I have the Wonder Bar schematic I was able to find. But I got the radio number now off the back plate here. I-61. Okay, I'm going to hunt down for a schematic for a 561. See what we get for that. I just don't want to make a mistake. Put the power on backwards. Okay, I managed to find the schematic for this on Radio Museum, and then it just struck me, duh, there's going to be two 12-volt inputs into this radio. One for the light and the other for the radio, just like the other radio. And the negative's the chassis. I just, you know, 'cause I'm not used to working on car radios, I haven't got that in my head. So negative on the chassis and positive 12 volts onto either one of these. One's going to make the light work and the other one's going to make the radio work. And it shouldn't be too hard to sort that out. Did I pop the light out? Yes, I popped out the light here. So with it hanging out here, I mean, even if I put the positive onto the wrong terminal, it's no harm done. It just makes the light come on when I want the radio to come on. Let me turn on the non-Allen meter. Okay, I think it's happy. We'll pick one of these, and then we'll come up here. Turn on. Yeah, it's on. I'm touching the light. Maybe the light's burned out. That's one of these inputs. The other 12-volt input. Maybe the light is shot. No, the light is good. What does the light actually read resistance-wise? I would say 5.2 ohms. I remember seeing that. It's sticking. Well, we can't stick it back in. I've removed the panel. So once again, just holding this on here with the radio switched on. There we go. Looks like 5 is the lowest resistance, and then if I go on the other one, it should get it open because I'm holding it on the light. Yeah. Okay, so I know which is which now. We can power this guy up. And the owner of the radio says it works. It's just quiet. Maybe we'll leave this hanging out. I'm going to take the bulb right out of it so I don't break it. Okay, did I say break? Break time. Break time is now. Okay, I think we're ready for an attempt. Got the power connected here. Negative to the chassis. Positive side to the correct terminal, which I double checked to be sure. This, as I mentioned, this radio has a vibrator in it and a OZ4 rectifier, which I really think you don't want to operate this on a low voltage. So I got the set turned off. I'm going to set my power supply to 12 over here. It is. It's set to 12 right now. No, it's not. It's set to 6. Okay, that's 12 or close enough. Turn that knob, it comes on. What could go wrong? Well, if I keep my eye on that current meter over yonder on the power supply, I should be able to maintain safety. You know, from the other radio, a couple amps was the drain. Oh no, there we go. What? Yeah, I know it snowed. There's nothing I can do about it. Both our cats got outside yesterday. We let them out yesterday for the first time. Our cats go outdoors. And I think that was pretty exciting. And they looked out the window this morning and went, oh my gosh, winter has come back. Is that right? Peanut, just wait. Peanut, I'm going to try this radio though. You're going to have to wait now. Everything ready? Okay, I got my eye on the... You look for the smoke and I'll look for the current. So that you've heard the vibrator go nyeh. The current draw did the same thing, but the current is the same over there. This is pretty noisy, isn't it? Oh, just did it again. Jumped up. Here comes the radio. Sounds pretty loud. But what are we hearing? My whole bench is shaking. That station down here, I have... Should get a station right in this area. There it is. So we're running this on a regular car antenna, which is laying right there, and just going up to my ceiling. It's right, yeah. So I think the low volume issue is, just judging by how much volume you can get on a noise signal here. Let's get one. The low volume is, the radio itself is low. That's what I would say. I'm just sniffing now, using my nasal sensor. Ah, it smells okay. No doubt some tubes warmed up and stuff warmed up a little bit. I'm going to smell a little bit. So this tube, I believe, is a gas tube, the rectifier tube. It doesn't have a heater in it, and I think they probably last forever. This guy's working, although it's noisy, but you know, you're in a car driving down the road. You think you're going to hear this, especially in a 1957 car, on 1957 roads. Let me turn that power supply off before I make a terrible mistake here. But that's a pretty strong power supply, that. Well, I think the next step is to get rid of these few old capacitors. Not that, this one. This one appears to be carrying the signal. It goes right out this wire, right into the radio. So I'm guessing this one's carrying the signal. This could be the weak. This could be the whole problem right here. Maybe. And I think that's really all I got to do on this side. 1, 2, 3. Don't think I want to go at this one. Here's another one here. This is a molded one. Probably should be changed too. And then there's a few capacitors over here, but we know there's lots of volume coming out, but I should probably change these ones too. Over yonder. Try the radio again. Yes, thank you, Peanut, for waiting. I appreciate it. He's giving me the look. When I see my cat's look, look at this cat. Give me the look, Peanut. You know, he's indicating to me he wants to go out. That's the indication there. Peanut. Peanut. Never mind the look. Give us the look. No, he's not looking up. This is we've had a lot. There he is. There's the look. Intimidation. He intimidates both my wife and I all the time with that look. He's one of the few cats we've had that looks you right in the eye and you swear he's a conscious entity in behind those eyes, just like we are. And other cats tend to look more at my mouth or at my feet. Not that I've got my foot in my mouth, but okay. Okay, Peanut. Thank you for being so tolerant. Here I come. Okay, so I've done only the one capacitor that I think is carrying the entire signal out of the radio and over to the amplifier. Replaced it with a really good one there, 0.1, and we're going to test it on my capacitor checker and see what it says. Okay, unfortunately I have to explain this repeatedly because I always have new viewers. So the way this works is it puts a DC voltage on the capacitor, and any tiny current leaking through it will cause this eye to close. You see how it's dark at the bottom? It's open. It'll close it. Now when I first push the test button, it's going to close because there'll be a current flow to charge the capacitor, but then a moment later it should open. If it's a good capacitor, like a brand new one, I can run this all the way up to 450 volts and the eye will open completely. Let's see, what does the old car capacitor do? So this is 50 volts, and if you can read it, it says 25, it's 50. Here we go. Oh my gosh, it opened right up. That's shocking. Okay, 150 volts. Still opening. I don't think this can be the cause of the weak output. This capacitor is not that bad. Made in Canada. Maybe that's why. Okay, but we will test the radio out with just this one capacitor changed, just because I'm too curious. Okay, switch is off. Let me turn on the power supply here. Okay, 12 volts. And we are fighting with the noise in here, so it's tricky. Tricky. Here we go. Vibrator vibrating. Station. Where'd the station go? Something's intermittent here. Volume? So hard to tell. I would say offhand that didn't make a hill of beans worth of difference in the operation of the radio. That's what I would say. So I think there's two ways to do this now. Test all the tubes, try to eliminate a weak tube, or keep replacing capacitors and just get those out of the way. And I think I'm going to just continue on with the capacitors. There's not too many. I need two more to do. Great. Okay. Sounds like another break time for me. I take a lot of breaks. Okay, 3 more capacitors to test. Let's see if they all do really well. I'm very surprised. I just think car radios would beat these parts to death. Vibration, heat, kind of out in the humidity. 1957 Chevys didn't have air conditioning, I'm pretty sure. 50 volts, what does the eye tell us? Not opening. Okay, so this is the bottom of the barrel capacitor. It doesn't mean it still wouldn't do its job okay. This one I'm sure it says 800 volts. Could be 600. Maybe that's 600 volts. There's that. I put in a 600 volt capacitor. Did I see that eye jump just now? Is there a charge left in this? Here we go. 50 volts on the molded. Okay, opened up. 150. Not gonna do it. Okay, so this is more typical of capacitors that I find in most radios of this age. I haven't bothered investigating what each one of these is doing because I'm just going to change them and see what happens. Here's a little guy. Okay, little guy. Just open a tiny crack. You can barely see it in the camera. Okay, so these guys all qualify for sure for a replacement. Good. I like to do that because I like to know what's going on. So you can see the nice shiny yellow ones I put in here. Now I'm going to do a couple more in the. Let's play this radio again. Let's see if this has made some kind of difference. I'm suspicious it hasn't. I'm thinking probably the low volume is a tube. Switch is off. Step to my left, please. Power on. Here we go. Gotta keep my eye on that ammeter on the power supply, just out of view there. This thing here. All is normal. When I first learned that there were vibrators like this inside these radios, I didn't believe it. That seems a lot louder. I'm going to wave the antenna around a little bit here. Turn off one noisemaker. Soldering iron. Let's turn down another one. Nope. But I think there's a lot more volume. Oh yeah. Oh yeah. Very good. So one of those capacitors is responsible, maybe all of them together, ganging up. You know they do that. Ganging up to reduce the output on the radio. So now there's a few more capacitors in this part of the radio, but I see by the clock, not really on the wall. I have a clock on the wall. Its batteries are dead. 12:30. 12:30 sounds like lunchtime. I think I'm gonna go eat some lunch. We'll do a couple more capacitors in here, and good. That's good. That's good. Turn off the power supply before something bad happens. It's good. Good. Okay, let me unveil what's inside here. Ooh! I chuckle. Look at that. Can't even tell what it is. 2 capacitors to change. Maybe 3. There's another big one up here. Just covered in dirt. I gotta sweep that dirt out of there as best I can before I do any more. If we just take a look at the schematic here for a minute, the two large bodied capacitors are here. One is here and one is here. And look at them, 0.47, 0.5. That's what's written on them. Usually I would say, well, 0.47, 0.5 is the same size. I've got some 0.5s, so I'll put a 0.5 in here. That's not a problem, and I'll put a 0.5 in here. But I read somewhere that you better stick to the sizes that are in the radio. This is a tiny difference, 0.47, 0.5. And the fact is, those capacitors are no longer these values. They've gotten old and leaky. Should I change this with just a 0.5? I don't have a 0.47. I'm pretty sure I don't have a 0.47. But these things are plus and minus anyway. Nothing special about those. It's a plus or minus, well, if we're 10%. So let's say you take 10% of 0.5. Oh my gosh, this is heavy math. That would be 0.05, and you subtract it. You get 0.45. Why did they do this? Did they? I don't know. I don't know what to think now. That these guys, I believe they take a beating because there's sparking going on. There's inductance in here. So you know, when these things open, they can throw quite a high voltage at a capacitor like this. So these are large, physically large. They may be intended for very high voltage, but I can see one of them says, the one that's visible, 100 volts. That's the one that's right. That's the one that's right across here. This one here just has 100 volts on it, and the other one, I'd have to guess it's the same. It's about the same size. I don't think there's anything special about it. Should I or shouldn't I? I think I should, because I don't think you want these to not operate or be, you know, not have the capacity that they should. So maybe I'll do the 0.5 first. I can test it and find out what's going on, make a better judgment about changing this one. But I think I'd be foolish to not change it, wouldn't I? Okay, let's take a look. I'm just going to put a little WD-40 on here to help clean it. If it does help, I don't know if it's going to help. .47. I thought the other one was .47. Okay, you know what? They both say .47. .47, 0.5, and say 200 volts. Looks like 200 volts on there. I bet you the other one's the same. No, I'd say it says 100. Okay, but I'm putting in a 600 volt capacitor. Yes, change them both. Okay, I got this one done. This is the one that goes to the chassis. I'm going to test it right now. The two of them look identical, and if I take them both out, it'll be a matter of a few seconds before I won't know which one's which. Great big capacitor here. Physically big capacitor. That is large. 0.5 is large. Okay, 50 volts. It might take a moment to charge up, so it may close and take just a moment to open up. Just untangle a few things here. Here we go. Fire one. That's just about all the way. 150 volts. Not going to open. Okay. Give this just a moment to discharge. Although I think internally it would leak itself out. So that's good. Okay. Now we just got to do the other one, which is the one that's right basically across the contacts. I think if I've got this straight in my head. This guy here, I cut him out. We'll test him right now. There. I put these clip leads on so I can't forget, you see, because what can happen is, my intention is to stop for a couple minutes, but then my cat, my wife, everything else goes on, and half an hour goes by, and I come back in here and I can't remember what I was doing. There we are. Can't go wrong if I leave a clip lead there. Okay. Yeah, you know what? I can go wrong. I'm sure I can go wrong. How about this filthy old capacitor from 1956? 56? That was a very good year. 56. Here we go. Not open all the way, so I'm sure it won't open on 150 volts. Yeah. So these were leaky, but it may not have been all that critical to the operation of the radio. The leak amount is tiny. In certain locations, yes, but in other locations, not so much. And after all, the radio was working. Okay, I put in a nice shiny yellow one in here. And then we'll be able to operate this radio again, and operate it with some sense, better sense of security now that some bad parts are out. Okay, one more left here. Now there are other capacitors in here, but there are a much more reliable type. With a lot of dirt on something like this, it's hard to distinguish the different parts. They all look the same. Dirt colored. And a speaker didn't like that. Somebody has a charge. Somebody's retaining charge in there. This thing. Yeah. Let's test them out. This is a good grief. Oh, this has 1,000 volts. I know in these car radios they have some high voltage concerns, if I can put it that way. Let's see if I can clean this up a little bit. For some reason I think WD-40 is going to do the trick. And the dirt is embedded right in the wax. You can scrape the wax off, and if you do it carefully, you'll be able to read. What's that? It looks like 0.0. Something. Probably 0.01. Okay, let me bring out my magnifier here. Just can't quite see it for sure. It looks like 0.01. The size of it suggests 0.01. How about 0.003? That's what it actually says. 0.003. 0.01, 0.003. That's a lot of difference there. Don't think the engineers were throwing darts at a board to figure out what size capacitor to put in. They had reasons. Good thing I looked at that more closely. Okay, here we go. What do you say? Look at that pop open. You know why? There, it's not doing so good at 250 volts. Because it's a 1,000 volt capacitor, it's been built a little bit better. And so it's done a little bit better. I think we're done with that. Okay, well I don't have a 1,000 volt. I do, but I don't know about a 0.03. 0.003. Don't get it wrong now. Okay. I'll see what I can dig up here. 1,000 volt 0.003. Thought it might be worth just looking at where that capacitor is. And the 0.03 is right here. And it's across the output of the output transformer. Why such a high voltage there? Well, maybe this is the answer. Well, no, you got 250 volts on either side of it. Excuse me. And then you got the signal voltage. So what's the concern about 1,000 volts here? Maybe I read that capacitor wrong. That just seems crazy. 1,000 volts. I think 1,000 volts is kind of problems over here, and maybe over here. 0.007. Well, we didn't see that one. The 0.007 one I mentioned is this guy here, this big one, and that's likely to be okay. So I think, you know, in terms of risky capacitors, they are all out, and we can operate this radio again. Just clear the bench, clear the bench. That's probably good enough, like that. Just let me put some tools away because I don't like turning things on with piles of tools everywhere, in case a panic ensues. Not that I'm expecting any kind of panic. Okay, now we're ready. Power's still connected. Switch is off. Step to my left. The power supply. 12 volts. Here we go. How's this sound now? Okay, watching the current. Whoop, what was that? It's just something falling off my. Just nothing. Okay, here we go. Watching my ammeter over there. Okay, same as before. Sounds different, doesn't it? You know, it didn't stall on the way up this time. Sounds different to me. Feels like it's vibrating a lot more. Feels like there's more vibrating power in it. Is that a good thing? I don't know. Loads of volume. Loads of volume now. Hey, before I turned this down, it wouldn't go quiet. Except for the washing machine running right there. So that station is 590. That's the strongest station in here. Strongest station I can pick up here in my shop. Let's just hunt around for a couple more. It's pretty much in exactly the right spot too. Sounds like there's a station there. That would be amazing if that's the case. Oop. $860. Sounds like there's some dirt on the speaker the way it's making a funny sound there, or the speaker is a little limited in that if you turn up if you get the cone traveling far enough, it gets rattly. Okay, that's great. So that's all I'm going to do today on the radio. Tomorrow I'm going to check out its alignment, maybe realign it. If I think there's some advantage to doing that, it probably is a little bit. The key thing is the antenna is in a terrible location. This is really meant to be in a car. with that antenna mounted the way it's supposed to be mounted, that would probably make quite a difference. Plus the cars travel. They'll travel away from my house and anybody's house, and away from all this computer noise and all the wall warts we've got going, and who knows what else. But you know what? Wall warts, some wall warts have transformers, others are switching power supplies. And this is kind of like a switching power supply here. Kinda, because of the vibrator in it. Okay, I think that went well. And tomorrow's the day. Tomorrow's the last day. What? Tomorrow, I hope, will be the last day with this radio. I should be acquiring the tubes needed to carry on with some other radios that I can get back to. And yeah, maybe the weather will even improve. Wow! Thanks a lot for watching, and see you on the next video.